Hello and welcome to our next lesson, case study number 8, video conferencing platform. Let's get started. Michael is a technology consultant focused on the legal field. He wants to create a video conferencing platform for virtual court proceedings that connects attorneys, judges, and legal professionals. The system should provide a consistent user experience, ensuring everyone sees the same proceedings. It must also secure sensitive legal discussions and work with old court systems as well as modern devices. Michael aims to build a reliable and safe solution that meets the legal industry's strict requirements for accuracy, confidentiality, and compliance. Here are the requirements. The system must provide a clear and consistent video and audio layout for everyone during court hearings. It should focus on security to prevent sensitive legal discussions. The platform must work well with old and new communication devices used in courtrooms. It must enforce strict access controls to ensure only authorized participants can join or watch the proceedings. The system must reliably store all details from each meeting, including audio, video, metadata, and timestamps. Let's go to the design. We always start with the user, so let's go ahead and get the user up over here. Now, first thing, security is important. Authorization is important, making sure that only the right people are able to access meetings, access video conferences, access history. So as we've done with a number of other case studies in the past, we go ahead and put our authentication service over here, which is a service backed by a key value store. Go ahead and click on do that. Indian authorization service. I'm sorry, not authorization. Authentication service. There we go. All right. Go ahead and expand it a little bit. All right. And then again, since it's even more important to make sure that the people who are logging in are who they say they are, we were going to also add that two-factor code email workers before to provide that ability to manage two-factor authentication. So we're going to go ahead and put that in here and put this here and name it appropriately. Two-factor code email workers. Okay. And then we'll go ahead and extend that out. Move this a little bit closer. Move this order to the front because I'm going to connect this up a little bit. Connect to elbow, do the usual things we do, right? Of course, it's connected to the user. All right. And of course, we'll have a web service where all of this is coordinated. So I'm going to put that though, maybe a little right here. I want to make sure I just have space for everything. We'll name this the web service like I mentioned. Okay, so remember we have this ability that we want to have must reliably store all details from each meeting, including the audio, video, metadata, and timestamps. And you're thinking about like creation of meetings, when the meeting happens, who are the people in there, users being authenticated and saved, and knowing who a user is. All this seems to call for a strong data service that that ensures that we have that data in a consistent format and that's easy to read and write from. So that's where we'll have our data layer service. Okay, so we have that's going to be important in this one. Data layer service. It's going to serve also as to serve as the metadata for each meeting. Okay, and actually I'm going to write that down just so that it makes it more clear of like some of the things that this data layer service is doing. I'm going to let's call it the meeting metadata service. Metadata service. We'll call that too. Okay. I'm going to extend this out so it's one line. Okay, cool. And then let's connect the authentication service, which is the web service, and that to the data layer service. All right. So, okay, so we have the security to prevent sensitive legal discussions. That's what we have the authentication service here. We have the reliably store the information of the meeting. But now let's talk about the meeting itself. So we take a step back here. When we're talking about video conferencing, what are we talking about? We're talking about a number of different people, right? That have just like how I'm recording this video right now. There's a camera, there's audio, and these are streams, information that's going from one place to the other, right? Now, when you're in a conferencing room, it's not just your audio and video that's important. Everybody's audio and video needs to be seen by everybody else. Now, there are a number of ways of doing this, lots of algorithms and ways to do it. The way that, again, the goal of these designs is not to provide the most advanced, amazing, absolutely like cutting edge design. Is to provide something where you can see how using these building blocks, you can actually lay out a functional application, and in this case, a video conferencing platform. So there's really stringent legal and security requirements in here. One of the main ones that says that first, it must provide consistent and video and audio layout for everyone during court hearings. In this case, they want that everybody sees the same thing. Everybody sees like who's talking and all the people that are talking in a consistent interface. Now, most interfaces now let you configure it. In this case, they really want to save that because of the archival part. We want to be able to save the document of what happened in that meeting in the same look and feel as how people experience it, so that there is no discrepancies. So in this case, there is an algorithm, a method of doing it. It's called an MCU, the multi-control unit. I will refer to it a little bit in this design. I'll add more information after that. But the idea here is that what we want to do is take all of the people's streams of the audio and video streams in real time, combine them all, and send it to everybody else in this unified format that everybody's seeing the same thing in real time. And that's what we're implementing now. Again, right now there's more advanced ways of doing this stuff that's that's more relevant to people's bandwidth and things of that nature. But we're going to talk about this more simple design, and what the benefits of this is that you have the consistency of what people experienced when they were in the actual conference is the same as what's being archived for future reference. So in that idea, when we go ahead and go into the authentication, go into web service, and they create a meeting and people are joining, real-time video is, it's high bandwidth, speed matters because you want to see and talk to people in real time. So this is when that's when perhaps a service that's interfacing with a relation database will not be sufficient because it will not have the throughput to be able to get the information to everybody. But we do have something that does work. If we go back to our video streaming case study, queues are very good at this. Queues can usually also be looked at as stream. A stream is really just a queue that's operating at high bandwidth, high speed. So it is the same building block. So right now you're going to see a number of queues and services and workers going in and doing certain aspects as information coming in order to make this happen. So first we introduce what I'm going to call the AV ingress service. And what this is like the first time where we're going to get AV standing for audio visual. Didn't want to write that out every time. So I'm going to say AV is when, okay, you have the video. The meeting is starting, and now you have a separate connection that connects directly to your client to the AV ingress service. So now your audio and video is being sent, each packet of information through this queue in this service. You're getting that information here, right? So just you and everybody else that joins are sending your audio video into this service. The next step here is that now you're going to see have a bunch of these things. I'm going to go over there, copy over there, put this here, and I'm going to call it AV, mixer workers, So this is not actually a service. I misspoke. A worker. The idea here now is that as this information is coming in, you want to take that and we want to process it. One of the things we want to process is that all of the information, all of the packets that are happening in real time at the same time period, all the 5 or 10 people, let's say, is in a conference, we want to combine all that information together so that you know, if the main person that's speaking maybe is in the big, you know, the large part of the screen, all the people that are in it with their video feeds, like, are in a smaller gallery feed, so you can still see that they're happening. You're listening to the person that's talking, and you hear the combined audio of everybody talking. You need something to take all that information from all these different users and combine them into a real-time feed. That's what this mixer workers are doing. It goes ahead and takes all the packets that from a particular timestamp, combines them together into one. So therefore, we have, let's go ahead and put this, if I could switch to the line one, there we go, to the mixer workers. Okay, now, let me go copy this. We still have another step here. All right, another step here, I'm gonna connect this, because we have another requirement. So it's not just that everybody has the same user experience, it's all combined into the same look and feel. We also wanna make sure that old and new devices can actually join and partake into this meeting, because, you know, there could be very old systems in the courtroom, but people might also be able to connect with their smartphone. It all depends on who's accessing. So we have these encoding workers, the ability to take that mixer and save it in different formats that some might be better suited for modern devices, some better suited for other devices, to make sure that you have this ability to, like, depending on what the client is, they're able to log in whether they have old or new technology. And that helps us with the whole, the platform must work well with old and new communication devices used in courtrooms. All right, so now that we have all the information coming in, it's all mixed into a single stream per timeline, and it's all encoded in different areas so that the client can subscribe to the one that is appropriate to their client. Then we have a AV egress service, so that all the users can be subscribed to the appropriate, you know, queue to get that information. So this is how they get that unified feed that they can interact with in real time. So I'll go ahead and put this, you know, connection all the way over here, and this is what connects to the user. All right. Oh, and I'm sorry, I forgot that, you know, of course, the two-factor email workers need to connect to the user as well. You see that, you know, you go in, you start the meeting. Once the meeting goes, you subscribe to this AV ingress service. Your audio and video are coming through. Your feed is being combined with all the other feeds in your meeting. Here, it's being encoded in different formats that's suitable for old or new devices, and then it's being released out that you're subscribed to. Then, and now you can see the video conference that everybody else is seeing in the right format in real time. So this is how that works. Now, we also, again, it's very important to have storage, that we have to be able to see old videos as well. And this is the great thing about the queue, is the ability to subscribe. Not only can users subscribe to the feed, we can have service subscribe to the feed as well. So what we'll have here is, hold on one second, I want to make sure I have, what we'll have here is that we'll have, I'm going to go ahead and put a queue to a worker here. We'll have these also subscribe to the feed, to that combined feed. I'm going to call this the archival storage workers. And that this would also be subscribed to the feed. All right. And I'm going to go ahead and put this here. And what this do is that it subscribes to the feed, it grabs the feed, and it actually sends it. Oh, let me make this a little bit better. It's always a little bit of a interesting process of making this work. Oh, I see why that happened. Okay, let me go do this. And then I'll go, and I'm gonna make this, there we go. All right, and then so this archive storage workers, let me move this over here. We'll move that data to archival storage, and we're gonna put it as a file store here, because this is, we want to have these meetings saved at rest, so that when we want to access that information, securely, we can do that by retrieving the actual file which those meetings represented. So we'll call it this the archival storage service, okay? And so now that service is going to have all the meetings stored. So again, so the same combined feed is not only going to the egress service that sends it out to the user in real time, but it's also being sent it to these workers and being saved in real time as well. So we have exactly what took place in real time, which is also fulfills lots of compliance and security requirements. We want to also make sure that this is also connected to the archival data service, because we will want to also, for archives, one of the things you do want to do is that you want to make sure that the metadata is also saved in the same place, so that if you looked at the storage service by itself without anything else, you're able to know which one is which. It has the ability that you can go into the storage service on its own and be able to retrieve meetings that way. Now, the data layer service still has that meeting metadata service, but you'll see this idea that you'll copy some of that metadata into storage, so that for archives, that becomes a standalone system. But hey, and now we have our platform. Let's go through our requirements. The system must provide a clear and consistent video and audio layout for everyone during court meetings. This is where these AV mixer workers come in. It should focus on security to prevent sensitive legal discussions. That's why we have this authentication service with two-factor code email workers. The platform must work well with old and new communication devices we use in courtrooms. That's why we have the AV encoding workers here, to make sure that there are different encoders that work with different devices. It must enforce strict access control to ensure only authorized participants can join or watch the proceedings. That's what the authentication service is used for. And then the system must reliably store all details from each meeting, including audio, video, metadata, and timestamps. That's why we have this archival storage worker subscribed to the real-time feed and saved it for future reference that you can get from the web service as well. All right. So first, let me just move this box over here. You might have just been like screaming at me ever since I moved it. So let me move that over there. Okay, now let's go to our key takeaways. First key takeaway: we use a central system to provide a consistent experience for audio and video meetings. This system includes a queue connecting to a service for streaming audio and video from each user, AV ingress service, and another to a service for streaming the combined audio and video from all users, AV egress service. All incoming user data is mixed, AV mixer workers, and encoded to a compatible format, AV encoding workers. This approach is called the MCU, Multi-Control Unit Video Conferencing Algorithm. And you can read more about that below the video. Second key takeaway: we will check everyone's identity before they enter the video meetings. This ensures that only the people who are supposed to be in the meeting can join. We require two-factor authentication for all users through an email code. Third key takeaway: we will save past meetings in a separate location for future reference, keeping the metadata in our data layer service. We do this by adding archival workers to subscribe to the final mix stream going out to users. These archival workers send the stream to the archival service to be saved for historical purposes. Thank you so much, and we'll see you in the next one.